Welcome to Study Loop.
So we want to know how fast the rider is rising when the seat is 16 meters above the ground level. So if we want to picture our Ferris wheel as just being a circle, we know that the radius is 10 meters. And then we also can see that since this right here would be 10 meters, if, say, they're 16 feet off the ground at that point, we have a right triangle right here where this is theta, and we want to find this. So with all this in mind, we see that the height of the rider at any time is going to be x plus the 10 meters, because this is 10 meters from the ground. So with that in mind, we see that the sine of theta is equal to x over 10. This is our x value. This is the 10 that we're talking about. So since the sine of theta is x over 10, we differentiate both sides and see that the cosine of theta, since the derivative of sine theta is cosine theta, we get cosine theta d theta dt is equal to 1/10 dx dt. Then we can rewrite cosine to keep it in terms of sine. So that's the same thing as the square root of 1 minus sine squared theta d theta dt is equal to, once again, 1/10 of dx dt. So when the height of the rider is 16 meters, we know that x is equal to 6. So in that case, we would have, since x is equal to 6, sine of theta is equal to 6 over 10. So our theta value would equal the inverse sine of 3/5 or 6/10. And what we'd end up getting as a result is that sine of theta equaling 3/5 would give us, since we know that the Ferris wheel makes 1 revolution per 2 minutes, d theta dt equals 2 pi radians over 2 minutes. So that means that there's pi radians per minute. So that's the rate d theta dt. So substituting these values in now, what we end up getting is square root of 1 minus 9/25 now, because it's sine squared, which we already know sine of theta is 3/5. Then we're going to have times pi, our rate, is going to be equal to 1/10 dx dt. So with that, we just do the math and simplify, and we end up getting that dx dt is equal to 8 pi. So what that tells us is that the rider is traveling 8 pi meters per minute.